Part 3 for chapter 23 on lipids. We are going to take a closer look of the properties of fats and oil. So remember, oil, a mixture of triacylglycerol that is liquid because it has a high proportion of unsaturated, meaning double bound fatty acid, and fat, where they are more solid because they have a higher proportion of saturated fatty acid. So what's the difference? The difference in the melting point between fat and oil is because of those differences between a single bond or a double bond. Vegetable oils are lower melting because they have a higher proportion of unsaturated fatty acid than animal fats. What does it mean? If you take a closer look at this is stearic acid, 18-carbon saturated fatty acid. Well, what happens is if you have single bonds, you're going to have a very straightforward chain, and that means that those can nestle together. When you look at unsaturated fatty acid, where you have double bonds, you have a kink in that chain. So instead of being flat, straight line, it's going to have a curve. So that means that it's difficult for those chains to fit next to each other. So when you compare those, this is on the left a fat. It's going to be flat, linear structures that can be very compact, so make it hard, and oil is more loose. So when you look at those, triacylglycerol are uncharged, non-polar hydrophobic molecules that are going to be here coalescing when stored in fatty tissue. Their primary function is the long-term storage of energy, and that adipose tissue, the fat that we pack up on our body, serves to provide thermal insulation as well as protective padding in addition to the storage of energy. So some of the properties in natural fats and oil: non-polar, hydrophobic, repel the water, no ionic charge. And if you look at here the difference between fats and oil, where fats have a high proportion of saturated fatty acid, oil high proportion of unsaturated fatty acid. So that's an example. Which of these two fatty acids has the highest melting point? Well, you're going to look at here the chain length, number of carbon atoms, and the number of unsaturated or double covalent bonds that are present. In general, the more carbon atoms present in a molecule, the higher the melting point. But the higher the number of unsaturated or double bonds, the lower the melting point. That degree of unsaturation is more important even than the number of carbon atoms when the number of carbon atoms is identical or very close or similar. So here, molecule A has 18 carbon atoms, 2 unsaturated bonds. Molecule B, 16 carbon atoms, so very close, 1 unsaturated bond. So even A has a slightly larger than molecule B. You would expect to have a higher melting point. Molecule A has 2 double bonds, but molecule B has only 1 because the degree of unsaturation, meaning the number of double bonds, is more important than the very close size molecule. Molecule B will have the higher melting point. So those are things that people have thought about. Margarine and solid cooking fat shortening are produced commercially by hydrogenation of vegetable oils. So what happened is people realized that unsaturated fatty acids such as oil are healthier to prevent atherosclerosis. But of course it's a little bit hard to spread your olive oil on your piece of bread in the morning. So people try to find a way, can we harden those unsaturated fatty acids? Yes, there is a way. Chemistry goes and helps. This is called hydrogenation. You can actually break apart that carbon-to-carbon double bond in vegetable oil by hydrogenating them to yield saturated fat. The way you can do this and controlling the extent of hydrogenation, monitoring the composition of the product, consistency can be controlled. Now we go from either partial hydrogenation, such as margarine, that's the rearrangement of the cis bond to trans bond in the partially hydrogenated fatty acid. However, research has actually found that those that we call the trans fat do not occur naturally pose even higher health risks than the saturated fatty acid. So just looking here, the chemical reaction, you need a catalyst and you need to have some hydrogen. You look at here, you have on the top an unsaturated vegetable oil, and you can break apart the double bond to make them single bond by adding those two molecules of hydrogen. So you have 4 hydrogen atoms. And when you do this, it's going to be a partial structure of hydrogenated oil, meaning that it's going to be harder. However, those, we call those trans fats. The problem is that the body cannot break them down and digest them. So we actually have more health risk than even when people consume saturated fatty acids.